Hi, I'm Dr. De Bruin and welcome back for part 26 in this narrated series of videos that sit alongside my GCSE Science Sprints shorts. We're back today with another relative atomic mass calculation. This is taught in the first unit of AQA GCSE Chemistry or Combined Science, the atomic structure and the periodic table unit. In this question, we're told that we have a sample that contains two different isotopes. When we say isotopes, we mean different atoms that are both the same element, so they contain the same number of protons, but because they contain different numbers of neutrons, they have different masses. So the oxygen-16 atom has 8 protons and then 8 neutrons, whereas the oxygen-18 atom has 8 protons and 10 neutrons. So where we're trying to calculate the relative atomic mass, what we're really saying is, on average, how heavy are these atoms? So the way to approach this is that if our sample contains 20% oxygen-16, we need to work out what is 20% of 16, and then likewise what is 80% of 18. There are a few different ways that you can do this depending on what you're most comfortable with, but mathematically they'll all give you the same answer. The first approach would be to use decimals, so say 20% is the same thing as 0.2, what's 0.2 times 16? The second approach would be to work out what 1% is and go from there. So divide by 100, which will give you 1%, and then multiply by the percentage from the question, which here is 20. And then our third option would be to identify that actually for this question, because 20% is quite a nice round number, we know that that's the same thing as a fifth. So we're saying what's a fifth of 16, which is 3.2. You'll notice that whichever one of those methods I use, I get the same answer, so it doesn't matter which one you're more comfortable doing. I would say the last one you're only going to be able to do for some questions, so here 20% is a nice round easy number that you can identify as a fraction you're familiar with, but if you're given something like 43%, you're obviously not going to be able to do that, and you're going to need to do one of the first two methods instead. Then, once we've established how heavy these oxygen-16 atoms are, we can do the same thing using your preferred method for the oxygen-18. And once we have those two numbers, all we're going to do is add them together. So I've got an answer of 17.6. And then to finish off, I can do a little bit of a common sense check. So your answer for relative atomic mass is always going to be somewhere between your heaviest isotope and your lightest isotope. Here we've only got 2, so we're basically saying it's got to be somewhere between 16 and 18. And it's going to be closest to the most abundant isotope. In other words, the one I have most of. So here I've got a lot more oxygen-18, so I'm expecting my answer to be closer to 18. So based on both of those criteria, 17.6 is a sensible, reasonable answer. Thank you very much for watching, and I hope that you're finding these narrated walkthroughs of the science sprints useful in your revision. If you are, then don't forget to like and subscribe, and also let me know in the comments which topics you want me to cover next.